Today's focus will be on the half-life problems found in the homework packet. First problem I'm going to do is problem number 1, which is found on page 4. Magnesium-56 is a beta emitter with a half-life of 26 hours. So I'm going to, as soon as I see a time amount or an amount, I'm going to underline it, okay? What is the mass of magnesium in a 1 milligram sample? So that's a different substance. That's an amount. Anything with mass is going to be considered an amount. Particles, or like when they're talking about individual things, that will be your amount. If they're talking about anything with the time unit, that's going to be under your time and half-life category. And then of that isotope after 10.4 hours. So that once again is another time unit. So if I look at my problem, I'm given 2 time units. So that's the one column I'm going to fill out first. Whichever column you're given first, that's the one, or whichever column you're given 2 pieces of information for, that's the column you're going to be filling out first. Okay. So I know that my half-life is 2.6 hours. So what that means is that after one half-life, it has been 2.6 hours. Which means after 2 half-lives, and notice it says add a half-life. It is not multiplication. I am adding a half-life each time. So I'm going to add another 2.6, which is 5.2 hours. Then I need to keep going. What you're going to do is you're going to keep going until you get to that 10.4. So I'm going to add 2.6 again, and I get 7.8 hours. And then I'm going to add another 2.6, and that's when I get to my 10.4. So I'm finally done. And I have used up 1, 2, 3, 4 half-lives. So it's been 4 half-lives. Now, all I have to do is fill in what is the mass. So I'm asking for the amount of magnesium-56 in a 1 milligram sample. So that's how much I start with. So that's going to be my initial. So even before anything started to decay, I had 1 milligram. Then after 1 half-life, which was 2.6 hours, I would have half of it. Notice it says to divide by 2. So that's going to be 0.5 milligrams. Then I'm going to keep dividing until I get to this final box. Okay, so it would be 0.25 milligrams, 0.125 milligrams, and then 0.0625 milligrams. Okay, and then rounded to the right number of sig figs. So this had 1, that had 2, that was the number 1, but that had 2, that has 2, that has 3. So we're going to round to 2 sig figs, and that's where we get that 0.063 milligram answer. Let's try problem 4 on page number 4. The mass of cobalt-60 in a sample is found to have decreased from 0.8 grams to 0.2 grams. So right away, I see 2 amounts, okay? It's 2 amounts in a period of 10.5 years. From this information, calculate the half-life. So this one, we're going to have to actually calculate the half-life. So I need to figure out my time component. The first thing, though, that you want to do is you want to fill out the entire column of the information where you have 2 pieces of information. I am going from 0.8, and that would be for the amount. So I'm going from 0.8 grams. So 0.8 grams. And I need to keep dividing by 2 until I get to 0.2. So it's going to be 0.4, and then it's going to be 0.2 grams. All right, so I'm already done. I can easily fill in my half-life part, the number of half-lives, because it goes by 1, 2. So now reading the problem, what it tells you is it says, hey, it took 10.5 years to go from here to here. So this is 10.5 years. How to figure out the half-life? What you need to do is you need to take this number, the total amount of time, divide it by the amount of half-lives it took, and that's where you'll get your answer. This one happens to be, I wanted to do it in green, 5.25 years. Okay, and rounded to the 1 sig fig because of these amounts. That's why you get the 5 years. But that's what I want you to do. Like if this, pretend, okay, if this had been, let's say 6, and it had taken 29 years. Okay, this is a separate problem, so pretend that. So I would have taken 29 divided by 6, and each half-life would have been 4.83 years, which means my first box would have been 4.83, and then to continuously fill up that column, I would have added 4.83 each time, and then by the end, after the 6th half-life, I should have gotten 29 years. Now that's just an example problem to do more than 2 half-lives, but it's it follows the same concept that we did for page 4, problem number 4. All right, let's do problem number 16, which is found on page 6. Okay, after 42 days, so that is a time thing, a 2-gram sample, so that is an amount, of P32 only contains 0.25 grams of the isotope. And then once again, it asks for the half-life. So we're going to be filling in the amount again because we know those two pieces of information. So you always start with your largest amount because you're always going to be decaying, which means it's always going to be going smaller. So each time, remember, you divide by 2 for this guy. And then that would follow 1, 2, 3 half-lives. Now, looking at this, what it said is that it took 42 days to get here. So this was 42 days. Okay? And now what we need to do is that we did on the previous problem. You're going to divide 42 divided by 3. And you get 14 days. And then to fill in the rest of the chart, remember you add a half-life each time. So I'm going to add 14. And this is a good idea just to check it anyways. So I get 28 days. And then if I add another 14, I should get 42. If I don't, I did something wrong. So that I did get 42. So I know that my final answer for my half-life is 14 days.